So today we'll be discussing the one more important topic in C programming, which is called as a bitwise operator. So bitwise operator is, I think most likely we can say that whenever we conduct any training sessions, most of the time we do not like to touch this because we think that, okay, which is quite complicated, but it is not like that. So it is a very simple topic. Only thing is you have to understand this, and it is also very easy. And what is this purpose? So we will discuss about all those things in this session actually. Whenever we are doing the coding, most likely we are not operating on the bits. We are operating on the some numbers, so 2 into 3, okay, or 3 plus 5, it is equal to 8. So that is nothing but number 1 plus number 2. So like this, we keep doing this. But what is bitwise operator we are talking about is in a number. For example, let me go here. Okay, let me go here. If I have number, okay, if I declare number is equal to 5, okay, this can be represented by, okay, in numbers means binary digit, right? So the 0, 1, 0, 1. So if it is a 2 to the power of this one, so we can see that 2 to the power of 0, 2 to the power of 1, that is nothing but 2, 0 is 1, and this is nothing but 2 to the power of 2 is 4. So 2 to the power of 3 is 8. So that means it is a binary representation, right? So usually whenever we are working basics, okay, usually this can be represented, if number 5 can be represented in the binary digit. So here if you see that there is a combination, wherever 1 is there, 4 plus 1, that is nothing but 5. Finally, it will be represented like this. So what are we trying to do till this time when we are working? We are doing the combination of number 1 plus number 2 or something like that we used to do. Okay. But here what we are trying to achieve is, okay, using the bitwise operator also we can able to do the various operations. So what is the advantage? The advantage is nothing but, okay, instead of writing the logic, if you understand bitwise, many operations we can do in real time without spending more resources, and performances will be very less. And it will be efficient for the development. That's why bitwise operators are the most prominently people are using it. For example, if I want to if I want to check simple, usually what we used to do, if the number is even or odd, just for our understanding of the problem. If I want to check the given number is odd or even. So what we used to do is just let me go to the code and then I will explain. Okay, let us do the program practically and try to understand. So let me go to our blue screen as usual. It is there. So let me go to this new screen. Change directory. Let me go to C colon. So I can go to app, something like that. So here, if I want to do that, so let me write one program. What I can do is, so let me write check even or odd. But this time I am not using what we call it as if condition or something like that. Without using that, I can do that. So that is what the beauty of bitwise operator. Sometimes it looks very crazy, but if you are having a internal understanding, then definitely you can code efficiently using bitwise operator. The main purpose of bitwise operator usage is it will consume less resources and the performance will be better. That's why people are expected to know the bitwise operator. Unfortunately, people are not spending the time. They know, they say that no, they know C, but unfortunately, they are not getting into the details of this. So anyhow, we will be discussing with an example. So what is our objective here? Check, even, or add. So that is the this one. Now let me write hash include stereo.h. Then what is it? Hash include new.h. Okay. Void main or int main, anything you can do this. Now, instead of we already know that how to take the input and all those things, scanf and all. Just directly when you go to the concept, try to understand this. Number 5. Now int the result. I wanted to tell whether 5 is odd or even. So that was the expectation. Now let me number ampersand 1. And so here number 5 is nothing but when you see in the binary format, this is like this. And we are doing what? We are masking with 1. Masking with, for example, if you have a face, okay, only eyes should be open. So eyes should be set. So that is what we are talking about, the masking. So now, if I want to do that masking, let us do masking with 001. So I wanted to do this with this only one bit. I wanted to do the mask to check whether the given number is this one. So now let me see that. So this is a bitwise AND. Ampersand, this is normal AND. This is a bitwise AND. So bitwise comparison I am doing now. Now let me see here. 5 and 1. Okay. Then is equal to %d, new line. So what is the result? So now let me clear the screen. Clear SCR. And then get ch. Let me use this. And we already know that, okay, what it is. Now, when you do this, so what is the value I'm going to get? If you are able to mask, when you mask with 1 digit, this value with 001, 1 is nothing but in 4 decimal. If I say that the binary value, this is the 1. When you say 5, it is done. And we are doing the combination of this. That means combination means, for example, in the comment, what we are doing, let me write 5 is equal to 0101. 1 is equal to 0001. Let me execute this. So binary AND means, so what it is? Binary AND means, so we are doing the AND means what? Both should be same. So now if I see this one, 000 same, 01 cannot be same, 00 same, and 1 is 1. So this is how we are getting the result. But 1 is odd number. It is not 2. If it is, if you would have got the binary, then this one, it is a the even number. Let me run this. So I got a 1. So result I got is 1. When you get a result 1, so 1 is odd. So that's why this is a, we are checking the when you do the combination, we are using this. So then what is this masking then? So what is this masking? So masking is nothing but, okay, it is a bitwise operation where special bits in a binary number are extracted, modified, or checked using bitwise operator, and this is called a mask. Okay, it is a binary number highlights which bit to be affected for the operation, which bit to be affected or checked for the operation. So what is the masking is nothing but, so what is the usage of masking we are doing here? Why are we combining with this? Like instead of if number divided by 2, the result is equal to 0. Instead of doing that, just we did a bitwise and, okay. That is just switching on or off, like that kind of operations we can do. By using specific bit, we can check the number. And using that, we can do a lot of operations on the masking. So masking is as good as on your face, you wear the mask, okay? Only eyes are open. So eyes means what? Just to see the word. Like this, here also mask is open, but now whatever the one we are talking about, the mask has opened just to look at that actually.
We don't throw the.
So this is what we should understand as a part of masking. So this is what we have to understand as a masking. We are checking whether the given bit is on or off, on or off. To see the outside world here, when I combine this, when I masked with 001, this is able to tell you whether the given input number is a odd or even. So this is how we can do the various various combinations of that. So now, for example, let me make 6. That is nothing but 4, 2. So here 1, and this is 0. So here 1. You should know what it is, okay? But let us try to understand. 1, okay. So we got a 0. 1 means odd, 0 means even, we call it as, okay. So that is the how number is divided by 0 is nothing but in general, if you get a reminder, we call it as a even number. If you get any other than that, we call it as a the odd number. So the same logic we are applying here through the bitwise operators. So bitwise operators we are using it, and using that we can able to measure the logic. So that's why. So this is how we call it as a bitwise operators. Our main purpose is alternative to the normal operations with less performance people are doing. So that's why bitwise or operators are used effectively for the performance this one, and we used to do that. So there are various kind of bitwise operators are used here. Bitwise and I have shown with an example. Similarly, bitwise or bitwise not, bitwise XOR, right shift operator and left shift operator. So these are the different bitwise operators. The people are using here. So using this, we can understand that. So let us understand that there is a okay, there is a B. Assume that 0, 0, 1, 1. Okay, this is the digit A digit. That is a that is represented in binary. So that means 2, 1. This is a 3. A is equal to 3, but binary representation is like this. Similarly, B is equal to 0, 1, 0, 1. So that is nothing but 5. Okay, this is another combination. Now bitwise AND means what? A and this one. AND means combination, right? Bitwise I am comparing. So 1 and 1, 1. Both are even, 1. On and off, off and on, off. And 0, 0, off and off. So this is nothing but AND logic. AND logic is telling that if whenever both are true, then only it is true. In any other cases, it is always false. The bitwise is going to be off stage. So this is what AND operator. Similarly, OR, if you OR, so OR means, so any one true, right? Any one true. So now if you go to 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1. So that means any one of the either A or B has 1 or a true flag, and we got the 1, 1, 1, 1. So this is called OR flag. So that is a bitwise OR actually. Similarly, exclusive OR. What is exclusive OR saying that? Okay. So alternative to this, for example, when you have 0, 1 combination 1, 1, 0 combination 1, But anytime 0, 0, same digit is continued in both this one, it will be 0. Here 1, 1 are same, then that time is also 0. So this is called exclusive like or, okay, or XOR, we call it as a XOR is 1 is 0, 1, 1, 1, 0, 1. Similarly, we have another operation called ones complement. Ones complement means, so just like if it is 0, we are complementing to 1. If this is 0, we are complementing to 1. This is 1, we are complementing to this. That means reverse process, opposite process. This is 1, then we are making it 0. This is called ones complement. There is a twos complement also is there. We are going to add 1 after completing the ones complement, we'll add it. So this is how we are using the various operation to do this. But what is the use of doing all these things? So maybe like we are using for whether the bit is set. For example, in embedded system, if I want to check okay, certain bit is on or off. If I wanted to check that the specific date, and also most of the time to handle the permissions like a Linux kind of environment or something like that, you should have seen the chmod, something like that. Okay, if you wanted to handle such things, usually we will use the permissions, read, write, execute permissions. So which one permissions they have, okay? These type of representation also people are using the bitwise operator. That's why people are learning the bitwise operators, especially at the low level coding. It is most useful actually, rather than application side. And also, if I want to toggle on and off, if I wanted to make it okay, we can use this. So that is why, but in the various cases, people are using the this one. So in the operating system, where people are using it, networking concepts people are using, embedded system people are using, game development people are using, and also file systems people are using. Especially the permission related bits to set in operating system level, they are using these type of combinations. Like managing the protocol packets and headers and all those things, they are using the bitwise operator. And embedded, this one, like hardware status, like if I want to see the hardware status and the status of registers, okay, if I wanted to do in the embedded system, people are using. Anyhow, I cannot get into that. That is out of scope. If someone has the knowledge on operating system, then they can able to figure out, okay, oh, read, write permission, or drive permissions, whether the files are hidden or opened. All these things are the beauty of bitwise operator. And similarly, like if I want to work in the player status, a paper player is alive or not in game development, okay, and where there's a file system hidden, read only, these type of things we can achieve through this one. So here, what we are trying to in this session we are trying to attempt is the why bitwise operator we should know the bitwise operator, and also how are we using it? How are we using it? Here, just I am giving the understanding of like a the understanding of the bitwise operator. So here just we are giving some one or two example to understand. That's it. Okay. So similarly, we have R operations, XOR operations. Okay, we can do that. For example, encryption and decryption. Okay, people are using it. Okay. So let us see a few programs so that through that you can able to appreciate it. So bitwise AND means we have understood both should be true, then it is true. Okay, that is this one. Bitwise are either one is input is like 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1. So this type of combination is we call as bitwise or. XOR means okay 0, 0, okay 0, 1, 1, 0. But alternative 0, 1 is on, 1 is off, then it is a 1. And 1 is 0 and another one is 0. So then it is 1. So this type of operation called a XOR operator. When we say bitwise or not, okay, it is like a ones complement or inversion. Okay. So if you 0, 0 is, we have replaced with 1, 1. 1 is there, opposite 0, 0. So this is called ones complement or bitwise not. Similarly, we have right shift and left shift operator. So we have a right shift and left shift operator. This is one of the important concept. When you shift, so shift means during the you might have seen that images. Okay, sometimes zoom in, zoom out, all these things they will do, right? And reverse the this one. So these type of operations, they easily they can use through the shift operator. So shift operator is also important. So here right shift means shift 1 bit, 2 bit. So high bit to low bit, okay. Or left shift means low bit to high. That's a right to left, you are moving the bits, or left to right, you are moving. So that is what we call it as a right shift and left shift. Usually, it is a moving of the bits numbers. For example, here 0, 0, 0, 0, 1, 1, 0, 0, 0. So just we are moving this. So when you move this, 0 moved outside, then 0, this place 0 will come, this place 1 will come, this place 1 will come, and additional 0 will come like this. So like this, by using shift operator, many operations we can do that. So that is what we have to do. Basically, and symbol, when you say set the bit 1, if both bits are this one, or we know n1 is there, exclusive or set the bit 1 if bit are different, not inverts all bits. Left shift means shift the bits to left, that is a multiply. So if it means that it is multiplying. When you are shifting left means 1 digit, it is multiplying. Right shift means it is dividing. Shifts bits into a right. So triple means shift right with a 0 fill. So this, using this, we can achieve a lot of things. So as I said, we can achieve the lot of things. So here some more, this one example, next level I have given 1101. If you use the symbol and 1011, so we can see that this is the combination. If both are same. Similarly, if it is a 1 bit differ, then it is true. So that we have seen. Similarly, it is inverted. Left shift in the sense we are moving, multiply by 2. It is you are shifting 1 means it is you are multiplying with the 2. So whatever the number you have done, this 1 is moved to here. So that then it becomes 0 here. It is 1 bit only moved here. 2 means 2 shift. So here 1101 become 1 becomes 0. This one is moved to 0th position. So that means here it came second. Then 0 becomes the third position. This 1 will be like this. But when you see this, it is almost same as a multiply by 2. If it is right side, if it is not, it is a divided by 2. So this type of simplification you can able to understand. So let us do few programs somehow, and we try to understand just at this moment what we have understood. What is bitwise operator? Why people are usually embedded side people will learn this actually. But application programmers who are learning basically C programming, they forget to learn this. And but unfortunately, in the interviewers are more interested, because if you are able to tell bitwise operator, they feel that okay, you have studied everything. And also effectively you can write a code if you're given a chance to write in the C programming or Java or something like that. So that's why the basic understanding of the bitwise operator is more important. Let us do some more few programs, whatever we have done. And at this moment, don't too complicate too much. Rather than complicating, just let us understand that, okay, bitwise operator is used effectively in various parts of system side coding, like operating system, networking, the like a security level concept if you wanted to implement, where less resources, less space is there. And all those spaces, people are using these type of bitwise operators only. So let us move on. So let us see this. Alt of save as. Okay. So let us try to do some more programs. Now we have understood what it is and I have shown you. Now let me write our example.c. Now let me write our examples means like a ORR hash include studio.h hash include panio.h. So void main, something like this, or int main, whatever you want. So int flags. So this is integer number I have used. What is the binary representation of this? Binary representation will be 1, 0, 0. Now, if I want to like a flags is equal to flags, and mask with R1. So it is nothing but just if you do that, set the first bit. What is mask? I already told you. Mask is nothing but the whenever you say mask, we wear on the face, eyes we will keep open. That means the eyes is important for us to see outside world. So likewise for specific operations, we also do the things here. So here instead of doing this, so we are doing this. Okay. For example, I want to activate a specific permission in a setting configuration in the system level or application level. So if I want to do such programs, rather than writing a lengthy code, and then they can use this type of, if you are proficient enough to understand the bitwise operator, you can use this. That is the alternative for that effective utilization. So now new flag will be, so we have already applied %d. So what it is, new line, okay, flags. So now, okay, so let me clear the screen. Get sketch. Now, if you look at this bitwise operator, so what we have done is now just now 4 we have represented. For our reference, I am writing here 0 0. Now we are flagged with 1 0 0 0 1. Okay, output should be, okay, output should be, let me write here. What is there? 0 0 0. R means if 1 is 1, so 1 will come. 0 0 0. If one digit is 0, this one. So like this, we are able to do that. This is equivalent to 5. So in binary representation, 0 1 0 1 is in decimal, we can represent as a 5. So now let me, we are expecting the output as a, okay. So it is telling that declaration syntax error because there is no semicolon. So we got a new flag as a, so this is how we can keep using this one actually for versions. Similarly, we have a, if I want to toggle, like for example, toggling in the sense, if I want to data transfer from one system to the other system, if someone has a knowledge on networking concept, okay, and in that kind of coding also people are using, okay, to secure the data transformation using the simple XOR based encryption. So for example, if they wanted to write, let me write, okay, F2 encryption. Just I am taking, make you people, anyhow, you people, I believe that you have understood what is AND or not. If you don't know decimal representation for the numeric numbers, then it will be a problem. And basically, whoever wants to get into a computer science, they will have they should have the basic understanding of mathematics. When see, computer science is a automation of a mathematics, as we know that, okay. At least you should know what is like addition, subtraction, and if I want to, what is a decimal system, number system. If you understand that, then usually you can understand the bitwise operator. In this session, we are not discussing about what are those things. I assume that you know the at least number systems very well. And main purpose of here is, if you are from the background of some computer science, you will be knowing what is operating system, what is networking, what is the encryption, decryption, all these algorithms, right? Even on permission related things means what, okay? So in those places, when instead of writing a lengthy code, the people are using the bitwise code. For that, some of the logic people are building, and that logic, how they are building, using bitwise operator, we are taking only special symbols like AND, OR, NOT, XOR. I am showing few examples on that, so that you can have an awareness about bitwise operator, what it is, rather than excluding this. Just I wanted to include that because basically as a beginner, it would be good to have an understanding of there is a concept called bitwise operator. The main purpose of bitwise operator is to improve the performance or effective coding. So that is what we are doing. Now, let me go with for understanding of the XR or something. If you wanted to do that, that also we can do that because we have seen and also we have seen the R. So just quickly, let me go here. Okay, studio.h hash include audio.h. Okay, so void main. Now we know all these standard set. Now declaration part, I can write into data some number. If you want to see the binary representation, because bitwise operator works on binary representation. So okay, you can do that. 1, 1, 1. 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 plus 3. 4. 4 plus 3 is 7. So this is how we can represent the binary representation. Those who are first time watching what is binary representation, please go and learn what is binary representation. Then it will be easy for you. So here our scope is just make you to understand how to operate with the bitwise operator. So similarly, assume that data, whatever you are sending a message is 7 in the binary format, and you are encrypted through the 5. That is nothing but binary. So you are transferring the data with some unknown number. Okay, so that recipient should not understand when he is sending the data. So I want assume that I want to send from a mail from the Bangalore to in US. So assume that the message what we are sending is a data. That is today I am telling you sending is a 7. Okay, but to send the data, I am modifying it using this key. That is nothing but 5. So that recipients, when they see the data, since if you do the XOR operation, they may not be knowing that, okay, what is the data, but when it reaches, once again, using the key, they can decrypt it. And if they decrypt using this key, then they get the original data. So this is what we call it as encryption and decryption. So this type of, usually people are talking about the security, cyber security or something like that, right? For that, they create this type of simple kind of encryption decryption. I'm telling you a very simple way, but but this is how we can use the binary operations. So let me write encrypted data. So before sending, I wanted to data I am taking. So encrypt with key. So if I do that, this is nothing but XR, right? This is nothing but XR. Similarly, if I want to decrypt and the opposite state, once it is reached there, okay, assume that I sent a message. This is nothing but a data is nothing but a message. Then once it is reached to the from Bangalore to a where is that like a US, some New York, okay. Then I can use this. This is encrypted data, okay. Then I may apply key here, okay. Same key because both knows public key. Assume that. Then once you do that, then you can see that the what is the original message. So encrypted %d new line. Okay, so this is encrypted, printed, so printf. So this is decrypted, which is recipient. Once he received, he's decrypting through the key, decrypted. So get ch and loads. Now let me run this. So sorry. Declaration. So here. What happened? It's only. Okay, okay. So I have declaration is there, so not here. So I have to add here. There is a one error. So you can see that 2 is, so when it is encrypted, it is showing as a 2, but actually you have sent 7. But when you receive it, I'm getting the original message. So this is the simple usage of XR message. What I have done is, assume that I am in Bangalore. I wanted to send some number, so like a message, that is 7. When it is passing through the network, computer network, by the time it reaches to if I send 7, the in-between hackers may know the data. So then what they can do is, they can hack the data and they can come to know that. To avoid that, I can use take the help of bitwise operator. For that, what I have created is one key, that is nothing but 5. So then I will be sending encrypted data. So the data with key, when I did XOR operation, I got the new key. So that is what is the new key? I have printed, that is 2. That is 2. Now I have a 2 received at the New York, but they know that before that I have already told them key is 5. So they know that what is the public key, what is the key. Using that key, once again they applied the XOR operation. Then actually they got the original message. That is nothing but a decrypted code. This is a simple example of how bitwise operations are exclusively used in this type of the message communication used in the encryption and decrypting world. So that's why it plays vital role. That's why in the interviews they will ask macros and also this kind of bitwise operations. But majority of time we are end our learning only if, else, while, do, while, for loop and writing this. But when you want to crack companies like product companies, where they are working clearly are embedded kind of systems where they are working on the hardware part of things, then definitely you should have the proper understanding of this. This is the one of the use case. I can say that we can use. Then we have understood how to use the AND, how to use the AR, and also we have understood the XR. Similar to that, we can do a lot of other operations like removing the duplicates from the array. Okay, if I want to remove the duplicates from the array, I can use the XR. So why we have to do the efficiency? Efficiency in the sense, I do not require to perform a for loop, while loop. I do not have a resources to do that at the embedded side. So in that situation, so probably instead of using the resource consuming the logic, we can use the bitwise operator. Let me take one more example. So where normally we should have used this, for example, let me take duplicate in an array. Duplicating. So when you go here, duplicate an array. So you removing duplicate items in an array. Yeah, the array means I think you people know that, right? Now already we have done that class. So in the like for example, if I want to do that as usual, stdio.h hash include conmu.h. Okay. Now, if I want to main or void main, you can use it. Okay. So if it doesn't return void. Now let me create an array. So I may be assigning some values to this. Let me take 5, 5, 3, 4, something like this. I have taken the array. So let me write unique is equal to 0. So I wanted to remove duplicates. For I wanted to read int I is equal to 0, I less than, how many items are there? 1, 2, 3, 4, 5, 6, 7, 8. That means 7 items are there. 0 because item is started with 7, I plus plus. So if I want to remove the duplicate, I have to write the list. So many logic I have to write. If I have to do that, if condition I have to check, I have to create one more list, one more array to copy. Okay, and then you have to create so this kind of one more array to copy. For example, if I have to check every time whether this item is unique or not. Okay, I have to use more than two for loop. But if you use like exclusive or like XOR, and easily I can write this logic using like unique. If this is a unique, already it is exist. So let me write, okay, array I, okay, which cancels the duplicates. Okay, which cancels the duplicates, and it will identify the, so what is the unique value. So for example, here 4 is repeated, 5 is repeated. So let me see that. Okay, what it will print unique. So print if unique, which is the unique value here. 3 is repeated, 4 is repeated, 5 is repeated, 2 is the only number which is not repeated. So printf the unique number in this number is, okay, this is as good as, it is exclusive or, so it is as good as like this. Okay. So instead of this, we have done like this. Printf, then let me write, then get ch. So let me write clear screen here. So let me write here. So unique number is not 3. All right. Two is not repeated. 5 is repeated. 3 is not repeated. Somehow I have done some mistake. 4 and 5 is not coming corrected. How many items? 3, 6, 7, 8. I plus plus. Some logic issue here. Yes, or something. Let me run this. also 2, 3, 5, one number 4. Let me write 5, 3, 4. Yeah, so unique number is 2. So here what we are trying to do is, like just okay. So what is the objective is here? We are trying to explain you that, okay. So using, so let us not worry too much about what is the operation, but we are telling practically this type of multiple for loop if you wanted to use, or instead of using multiple if conditions, okay. By using, if you really wise or intelligent, at this moment, if you are a beginner, definitely you cannot able to understand, but only you can able to understand is, okay, like what exactly I'm doing. XR means what I'm comparing. That's all you are able to understand. Okay. So what is and, what is or, what is not, and what is one's complement. Those things you are able to understand. But practically, when you go to the higher studies, where you will be learning encryption, decryption, operating system, permissions related things and all, that time it will be very clear for you. At this moment, okay, just remember that what is bitwise operator and what is the purpose of bitwise operator, and also remember that, okay, this will help you to minimize your what is the number of lines of code and use less resources. That's all you remember as of now. So don't worry, rest of the things, okay. Similarly, if you want to use not, okay, so that is one's complement, okay. That is we have understood, and R, XR we have understood, and if you want to do the what is called the what we call it the not or one's complement, so you can do that. So let me do quickly to show you how to we use this one's complement. Let me write hash include dot h, and similarly void main, I will write it. Okay, so what is one's complement? Okay, so let us understand. So let me take one number, some number 5. So that is binary representation for this is 100101, and int result. Okay, what is number? This is a one's complement. So then what should be printed? Printed the result. Result. Okay. So let me write that for clear screen. Dot h. So declaration. So here. So get ch. So we got a -6. -6. It means that, so we are given this number. So here 0 is replaced with 1. 1 is replaced with 0. 0 is replaced with 1 and 0. So this number is 0, 2 to the power of 0. This is 2 to the power of 1, 2. This is 4. Okay. 2 to the 2 is 4. This is 2 to the power of 4. So 4 plus 2, 6. So I think this is the 6 number. 6 is the one's complement. So likewise, you can do that. Usually, they are using in the flipping the bits. So 0 on to off, off to on, like a flip the registers, memory management. Okay. In those scenarios, when we are writing a code on the memory management stuff, we required this type of coding. So usually converting from like inverting the bits or doing the combinations of that. Okay. Then we can achieve the memory management effectively. So that kind of code, if you wanted to write, people are using it. but you do not require to worry about too much about that. But you remember that complements means what or not means what. So this is what you have to use, and you have to do the operations. Similarly, we have one's complement, two's complement. If someone studies digital electronics subject, or then you can understand what it is. And also people who are from the mathematics, they can able to understand. So another important, the last but not least, is left shift and right shift. We said that left shift is nothing but multiply by to the power of 2, multiply by 2, and opposite side is dividing by 2. Okay. When we wanted to do that, okay, let me close this. Before closing, quickly understand where we use these complements. We'll use in error detection, and we can do the cryptography in such situations we can use, and memory management kind of solutions if you want to provide, we'll be using the complement. Now, next concept we wanted to understand is let me go here. Shift, left shift and right shift. So we wanted to understand. So as we know that left shift means shifting like this. Okay. It is nothing but multiplying by 2. So that is what we can do that. So where do we use this one actually in the real time use case? Fast multiplication if you wanted to do that. The faster multiplication if you wanted to do that, especially game development, people are using it. Scaling the images. That means if I want to zoom the images, or the transfer the images from one location to the another, like a transformation within this. Okay. So those type of scenarios people are using this one. So especially games like increase the zoom in, zoom out, all those things. If they wanted to write, they will be having an understanding of what is left shift operator. For our understanding, we are not going to that level because we are not doing any gaming coding here, but we are trying to understand. So what it is, we are feeling that, okay, how they are using to achieve that. Let us understand first basic foundation, what we are learning. What is left shift operator? So studio.h hash include conio.h. Okay, so int main. So int num3, num is equal to 3. So that can be represented in binary like 0, 0, 1, 1. Then int result is equal to num left shift 2. So this one you do this. Okay. So we are multiply with 2 digits. Printf 3. It is as good as 3. 2 times we are shifting. 2 times we are shifting. So it is coming 12. Okay. So you have to understand means you have to write 0, 0, 1, 1. So when we shift here, so first time when you shift, it will be 0, 1, 0, 1, 0. Second time when you shift, it will become 1, 1, 0, 0. If you look at this, okay, 2 to the power of 0 is this, 2 to the power of 1 is this, 2 to the power of 2 is 4, 2 to the power of 3 is 8. 8 plus 4 is equal to 12. So this is how it is shifting the bit, and it is as good as multiplying the value. So multiplying the value. Okay. So this is how we are doing the shifting actually. So main use case is when we are when you are increasing, improvising. Okay. In such scenarios, logic people are using the left shift operator. So like usually in graphics design, gaming, people are effectively uses this actually. And similarly, the last this one is the right shift. There it is opposite process. It is a opposite process. Let me write quickly. Write 1616 binary representation. I will write. I can do 4 zeros. So this is what I am doing. So instead of left shift, I will do the right shift here. Then 2, it is just as good as dividing. Okay. So here 16. Okay. Does D2. That is as good as that. So result. So then here 16 means I would have written 100. Binary representation is this. If you use 2 means 0, 0 like this. Okay, then right shift, if you do that, okay, we need to get so binary representation of this. So now let me, output should be, okay, 0, 0. Okay, real time. It should be, I think, right shift, right? So right shift means, okay, 2 times we have to do this. So 100, this is a here 1, 1, 2. Next time it is shifted here. So this was there. Okay. Once it is shifted, it becomes 0. And like this. Second time it is shifted 0, 0, 1, 0, 0. It should be 4. So we got the 4 answers. So this is how we can do the right shifting. So where do we use it? For example, if I want in audio file, I wanted to reduce the noise or reduce the sound. Okay. So then people are using dividing concept. So this is the right shift people are using that. So image size, I wanted to, instead of like a zoom out, I want to zoom in. I want to reduce the size of the image in the graphic design. So then we can use this type of concept. So likewise, people are using the bitwise operators are effectively. So this is, we have seen what is bitwise on, bitwise or, and bitwise exclusive XR, also not, and also we have understood left shift and right shift. Also, we have realized that the main purpose, especially in the reality, that less resource consumption get the good output, effective output, and it will be used in all different types of the hardware related, nearly hardware related kind of solutions. It may be an operating system, management, so cyber security, at the base level algorithms, people we can use it effectively actually. So with this note, I wanted to give an idea. I wanted to give an idea about Bitwise. So this has given, I think this session has given a clarity to all of you and whoever is joined through here and also through YouTube. So any questions before concluding? Anyone has any questions? No? So let us quit this. And any questions from anyone? Okay. If there is no questions, it's okay. Thank you very much for joining. Thanks a lot. Okay, have a nice evening.
Thank you, sir.
Thank you.